Okay, today I want to go ahead and take a look at Lesson 1-3, Segments and Segment Addition. Unlike a line segment can be measured because it has two endpoints. So here I have this. It says a segment with endpoints A and B. What is the notation? How do I write that? Well, if we're talking about a segment, we can say AB with a bar, or you can call that BA with a bar. And then here I have a line that contains points A and B. So if we're talking about lines, you write the 2 points, put a line above it, or you can call that BA with a line above it. So here, line AB, line BA. Okay. The measure of segment AB is written as AB. What this means is that if I'm talking about the actual value of a segment, like for instance, length, then I'm talking about the language of algebra. Okay? I'm basically removing the bar. Okay? So if I were to say this segment here, call that XY, is 2 centimeters, then I'm going to say XY is 2. Okay? But if I were to name this segment, I will call that simply segment XY without, an equal sign and a 2. Because, again, this is the language of algebra, and then this is the language of geometry. Okay, hopefully this makes sense, and hopefully you remember what a segment looks like. Of course, this should look like this, and a line should look like this. Okay, hopefully y'all remember that. Distance and midpoint between 2 points on a number line. We have this thing here, distance on a number line. Suppose that I have 2 points on a number line, and if I want to figure out the measure between the two, I'm going to use this formula. It says the measure of AB is equal to the absolute value of the first x minus the second x, or you can use the second x minus the first x, and it does not matter, okay? So the notation here, that little 1 here and that little 2, is just to differentiate the two x's, right? Because these are all x values, and we're differentiating them. So this is going to be our first x, and that's going to be my second x. Now, why do we care about the absolute value? So let's go ahead and write that down. Absolute value. You probably have seen that bar before, or those 2 bars. Absolute value. You've seen these 2 bars. It makes a negative number positive, right? But really, do you actually know what that means? It's what the absolute value is how far, is basically how far the number away from 0 is. So if I were to say, okay, well, what's the absolute value of -5? Well, we got to compare -5 to 0. So I'm going to draw my number line. And I have 0 and... Actually, I should put -5. Oh, nope. I'm screwing up again. 0 and -5 here. Well, what's the distance between -5 and 0? 5, right? It's positive. Why is it positive? Because we are using distance. Now, have you ever heard of negative distance before? I haven't. I've never heard of -2 inches or -5 meters. I've never heard of that before. Distance will always be positive, hence the reason for those absolute value signs that you see here. So let's go ahead, before we take a look at these things, let's go ahead and take a look at this. It says the midpoint of a segment, midpoint on a number line. If the coordinates of the endpoints of a segment are, the first x and the second x, then the coordinate of the midpoint of the segment is, well, x sub 1 plus x sub 2 over 2. Okay? So you have a midpoint on a number line. Let's say that you have, again, a midpoint, and I call that -5, and I call that 5. Well, the distance between -5 and 0 versus the distance between 0 and 5, they should be the same. The distance between these two should be 5, and the distance between that two should be 5. And we use that formula. We take this plus this, you add them, divide by 2, hence you get 0. That should be the midpoint. Now, one thing that's super important that we have to understand, the midpoint cuts the segment into two congruent parts. Super important that you understand this, okay? Let's go ahead and take a look at this number line. And it says, find the measure of BE. So we are in the language of algebra. Where the heck is BE? So here's B, here's E. We got to find the distance between the two. I'm going to go ahead and use this formula here. I take the absolute value of x sub 1 minus x sub 2. And then I'm going to plug it in. Let's call this x sub 1. And I'm going to call that, where is E? Right here. Plug it in. So I have negative 6 minus 2. Negative 6 minus 2, you can put that in your calculator, you get what? Negative 8, yes? So you got the absolute value of negative 8. Absolute value of negative 8. What is the distance between negative 8 and 0? Again, we're talking about distance, so it should be positive. So if I were to compare negative 8 and 0, you're going to tell me it's 8. So the answer here is actually 8. Okay? Let's take a look at B. Determine whether CA and ED are congruent. Let me go ahead and remove that. So where the heck is CA? CA is right here. Or C is right there. Here's A. And let's call this x sub 1. I'm going to call that x sub 2. Why not? So CA is equal to, don't say segment CA. That's completely wrong. It is measure CA. The measure CA is equal to negative 7 minus negative 4, and don't forget the absolute value. And I have that negative 7 minus negative 4. Because I have that minus negative, that's going to turn into a positive. A negative times a negative is going to be a positive. So let me go ahead and turn that into a plus sign. So then negative 7 plus 4, that's going to give me negative 3. Absolute value of negative 3. Hence 3. Okay. Let's go ahead and take a look at ED. So here's E, and here's D. Let's call this x sub 1, x sub 2. Okay. So this is x sub 2. So I do ED, which is equal to the absolute value of negative 2 minus 2. So negative 2 minus 2 is negative 4. The absolute value of negative 4 is just 4. So determine whether CA and ED are congruent. Are they congruent? Absolutely not. So this is not congruent. Not congruent. Okay. C. Determine the midpoint of segment DE. Okay. So I'm going to go ahead and use this formula right here. X sub 1 plus x sub 2 all over 2. Determine the midpoint of segment DE, which is right here. So this should be, so the midpoint of DE is equal to negative 2 plus 2, okay, because I'm doing x sub 1 plus x sub 2 all over 2. Well, I'm going to go ahead and handle the numerator first, so the negative 2 plus 2 is 0, and then keep the denominator. Now simplify. What is that going to give me? 0 divided by 2 is just 0. So the midpoint of DE is 0, which absolutely does make sense, right? So negative 2, 0, and 2. This number is in the middle of negative 2 and 2. So the distance between negative 2 and 0 is 2, and the distance between 0 and 2 is 2, okay? D, find DF in the midpoint of segment DF. Okay, DF. So here's D, here's F. So I'm going to go ahead and take the absolute value of negative 2 minus 5. Oops. Negative 2 minus 5. That's going to be negative 7. So that's the answer. DF is 7. To figure out the midpoint, I'm going to do negative 2 plus 5 all over 2. And that's going to give me, what, 3 halves? 3 halves. So 3 divided by 2 should be 1.5. Okay? So that's the midpoint. All right, the next thing I want to go ahead and take a look at is this. Between any 2 points on a line, there's actually, well, we have a line here, and I see 4 dots. Does it mean that this line contains 4 points? No, remember, a point is a location. Yeah, that's a location, that's a location, that's a location, that is a location. But again, we cannot neglect the fact that these things here are also locations. And this is a line that extends forever and ever and ever and ever and ever. So that means that this is infinite. So between any 2 points on the line, there's an infinite amount of points. In the figure, point N is between points A and B, but point P is not, because point P is not in the inside of that line, or on that line to be exact. Okay, here we go. Segment addition postulate. So if A, B, and C are collinear, then points B is between A and C if and only if the measure of AB plus measure BC is equal to AC. What this is really saying is that if I have like a chocolate bar, yes, and I break it into 2 parts. And then this right here is like what, 2 units, and this right here is like 5 units, okay? You're saying that I have this whole chocolate bar, which is 7, right? This whole chocolate bar is 7 units. And if I break it, I get this 2 units and this 5 units, basically saying, okay, I have a part plus a part, and you're going to give me that whole thing, okay? And this is the same case right here. So, here's my segment. This is my whole segment, and if I break it, I got a part plus a part, which will give me that whole thing. So segment addition postulate allows us to say that, okay, well, if I look at this line, this is a part, this is a part. If I add these 2 parts together, that's going to give me segment AB. Okay? Really, I want you to understand this. Part plus part is equal to whole. Okay? Think chocolate bar. If you can think chocolate bar, you have that whole thing there, you break it into 2 parts, you got a part plus part, put it together, glue the chocolate bar, you'll get the whole thing. Okay? So let's go ahead and practice drawing and setting up an algebraic equation for segment addition. B is between A and C. So suppose you have segment A and C, and if B is in between those 2 points, it doesn't have to be in the middle. It doesn't have to be the midpoint. It has to be between, right? So if I have this whole thing here, well, it's going to equal to AC. Okay? But we got to take a look at the parts. This is a part here, so I'm going to go ahead and put AB. And then since you're gluing them together, you got to have that plus sign. And here's another part here, BC. So AB plus BC is going to give me that whole thing there, AC. Hopefully that makes somewhat, sense. B, M is between H and K. Does that M mean, or does that between mean like right in the middle? No, it just has to be between somewhere between H and K. So let me go ahead and draw my segment. HK is the whole thing. M, let's put M right there. Then I'm going to go ahead and say, okay, that's HM plus MK equals that whole thing, HK. That is how you're setting up your algebraic equations. That's really geometry. You're learning how to set up equations so you can do the algebra. Okay, C, Y is the midpoint of X and Z. Well, midpoint, that means it has to be in the middle. So if I draw XZ, then Y has to be in the middle. And if Y is in the middle, we understand that this and this, they have to be the same distance. They have to be congruent. And I'm going to draw these slashes, which indicates they are congruent. So we can say that segment XY, this thing right here, is equal to, measure of XY is equal to YZ. If you're doing an algebraic equation. But if you're talking about geometry, yes, you can do this. But we are talking about algebraic equations, so this is the answer. Okay? Alrighty. Find the measurements of the following segments. Figures are not drawn to scale. Okay. FE. Try to figure out what FE is. My goal here is to figure out the length of this segment. I have my part, but I don't know that whole yet. So let's write that down. So I know what FE is, and one of the parts is ED, and the other part is DF. If I plug everything in, this is 1.2 plus 1.9. Well, what the heck is FE? This is basically algebra. Your answer is 3.1. That should be 3.1. My arithmetic is horrendous, right? So that's 3.1 centimeters. So FE is 3.1 centimeters. Okay? AC. Again, you have to follow the thing about part plus part equals whole. Okay? This is basically an algebra equation. So I have my part plus part equals my whole, right? So AB plus BC is equal to AC, okay? This right here, I got to combine like terms. X plus 2x is 3x. And then I'm going to rewrite the right side. Then I'm going to subtract both sides by 2x because I need to get x by itself. So I have x equals 5, okay? Now, am I done? What does the question say? Find the measurements. It did not ask me to find x. Yes, x is super helpful, but I need to figure out what the measurement of AC is. So what is AC? Well, AC is currently 2x plus 5, right? And this x is going to be super useful because I'm just going to plug it in. So equals, AC is equal to 2 times 5 plus 5. 2 times 5 is 10 plus 5, that's 15. So this means that AC is 15 units or whatever. It doesn't have units, but that is the length of this particular segment. If I plug this in phone and figure out what AB is, well, that's just going to be 5. And if I plug that in, that's going to be 15, right? So 5 plus, oh no, this is going to be 10. So 5 plus 10, that's going to be 15 right here, okay? Number 3, find the value of x in RS if S is between R and T. So words, right? We have to draw the picture. So let's draw the picture. So S is between R and T. So R, T, and here's S because it's between. RS is right here, that's 2x. And then ST is 5x plus 4. And the whole thing here is actually 32. Again, think part plus part, which is equal to whole. Think that. So we have my part, I have my other part, and my whole thing, this whole chocolate bar here, is 32. Okay? I'm going to combine the like terms. And I'm going to subtract both sides by 4. So then that's going to give me what? 7x is equal to 28. So x is equal to 4. Okay. Am I done? Well, it said, yes, find x. I got that, but I need to figure out what RS is. And RS is right here. So go ahead and plug that in. I have RS equals 2x. Replace the x with 4. And that's going to give me 8. So that's my answer. Okay. Number 4, find the value of x in AB if B is the midpoint. Oh my goodness, you need to star this. Find the value of x in AB if B is the midpoint between A and C. And if you're talking about the midpoint, please do not use this formula. Please do not use the formula. This is only trying to figure out what is the actual midpoint, right, is trying to figure out what the midpoint is using this formula. But over here, the midpoint is already given. You don't necessarily need to find it. So in this case, for segment addition, if you're talking about midpoint for segment addition, you will use part equals part. So important. The midpoint is already given. See, B is the midpoint. I don't necessarily need to figure out what B is. I'm trying to figure out what A, B is, and also X. So here I have, let's say I have the segment here, and then B is the midpoint. It has to be straight in the middle. So we can call that B is between AC, and this length here is congruent to this length here. Okay, so I'm going to go ahead and plug this in over there. So the AB is 9x minus 5, and also BC is 7x plus 3. And since B is the midpoint, it splits the segment into two congruent parts. Therefore, this and this are equal. So I have 9x minus 5, which is equal to 7x plus 3. And then I'm going to go ahead and subtract both sides by 7x. So you get what? 2x minus 5 is equal to 3. And then I add both sides by 5. Yes. 2x is equal to 8. So x is equal to 4. Okay? And then since I have that, I figured out what x is. I need to figure out what AB is. So this is AB. AB equals 9 times 4 minus 5. That's 28 minus 5. So your answer should be... Oh, did I screw up somewhere? Oh, wait. 9 times 4 is not 28. 9 times 4 is actually 36 minus 5. Therefore, that's 31. Okay? So that should be 31. All right, there you go. One more time, I really want to emphasize this. This here, midpoint on a number line, is you're trying to figure out what number or what the midpoint is between the endpoints. Over here, you're going to do part equals part if the midpoint is already given and you're doing segment addition, okay? If two figures have the same shape and size, they are what we call congruent. First of all, if we take a look at these segments here, okay? We see that AB is 1.7 and CD is 1.7. They are definitely equal to each other. So segment AB and segment CD are congruent. If two figures have the same shape and size, they are congruent. If two segments have the same measure, then we say are congruent. Those slashes here, you see these slashes? Every time we see figures congruent, we gotta use, or specifically, if we see that these segments are congruent, we have to draw these slashes here. So they indicate congruent. They indicate congruence. Sorry for my handwriting, by the way. So congruence. There's a symbol for congruence, and we use that. It's an equal sign with a little squiggly above it. Therefore, we can actually say that segment AB is congruent to segment CD. Okay? And this, again, this is just the language of geometry. Perfect. Okay. Now try these. WX. Okay, so here I have this figure, and we see that, okay, this whole thing is 6 centimeters. And we notice that these got these slashes here. That means that this and this are congruent. So what can we say? Well, since these have two tick marks, we can say that segment WX is congruent to segment XY. Okay? If you have, I really want to emphasize this. Trying to think of something. Let's try 4. So let's suppose you have a midpoint here, and I call this A, B, and C. B is the midpoint, and this whole thing here is 4. If this segment here or if this midpoint is part of this segment, well, what's going to happen? Well, this segment here and this segment here are incongruent. So how long is this and this? Well, this is going to be 2 and 2. Yes? Okay, here we go. Determine whether the pairs of segments is congruent. Segment MN is right here, so MN is equal to 4x, and RQ is 4x as well. So what can we say about these? Yes, segment MN is congruent to segment RQ. Okay, and that's the answer. Thank you.